Good morning, children. Today's topic is area related to circles. In earlier classes, we have studied finding perimeters and areas of some simple figures like parallelograms, rectangles, squares, and triangles. In our daily life or day-to-day life problems, we come across many objects which are circular in shape, like bangles, circular beds, a rupee coin. They are of that is why the problem of finding the areas of circular regions is of great practical importance. So in this section we shall discuss the finding the perimeter and areas of special parts of a circle known as sector and segment of a circle. So before discussing the sector and segment of a circle, we recapitulate the basic terms or related terms to a circle. First one is the chord of a circle. One is the chord. We know that a chord is a line segment whose two endpoints are on the circumference of a circle. Like if we draw a circle here, this one. We take any 2 points on the boundary of a circle. Let this be a point A here and this one be point B. If we join the points A and B like this line segment is said to be a chord of a circle. A chord is a line segment whose two endpoints are on the circumference of a circle. And further this chord divides a circle into two arcs. One is the minor arc and other is the major arc. We call this one as, let this be a chord, this one is a chord. And we take point another here, that is C. This chord further divides the circle into two unequal arcs. One arc is said to be minor arc and other is said to be the major arc. Here minor arc is this ACB and the major arc is this A, D and B. So minor arc is A, C, B, and the major arc is A, D, B. Then next point is diameter of a circle. We know that diameter is also the longest chord of a circle, but it passes through the center of a circle. Like let this be the center of a circle, and if we draw a line which passes through this center, let the line be C and D. This CD is a line segment or PQ. This is PQ here. PQ is a line segment which passes through the center of a circle, and this center, this PQ divides the circle into two equal arcs. Each arc is known as semicircle. So chord divides a circle into two unequal arcs, minor arc ACB and major arc ADB. But the second one is diameter. Diameter is here PQ, which passes through the center and divides the circle into two equal arcs. Equal arcs and equal arc is said to be here two semicircles. Now third one is the central angle. What the central angle is? An angle subtended by an arc. Either it is minor arc or major arc. An angle subtended by an arc at the center is said to be the sector angle. Let us draw another circle of radius R. Now third point we have discussed here, central angle. So we draw a circle here, this one, and this one be the center of this circle and call the center as O. If we take 2 points on here, A and B, means AB is an arc here, this one is an arc. Its subtend angle at the center is OA join and OB. The sector angle or the central angle subtended by an arc AB at the center is this one. So this angle is said to be the central angle. This angle is known as central angle. This is known as central angle. Now another point is here, fourth point is the sector of a circle. The sector of a circle, we know that a region between two radii and corresponding arc of a circle. Means if we take the same circle and O is the center of this circle, A and B are 2 points on the boundary of a circle or on the circumferences of a circle. A region between two radii and corresponding arc of a circle, means this one, which we shade, this one, is said to be the sector of a circle. This one is sector of a circle. A region between two radii and corresponding arc of a circle is said to be the sector of a circle. But this sector is minor sector. That is, this one is minor sector, because two radii and a corresponding arc divides a circle into two sectors. One is the minor sector and other is the major sector. This one is minor sector and this whole part is known as major sector. This is major sector. Known as major sector. Now another point is here, central angle. Then we have fourth point, sector of a circle. Sector of circle. Now we have another point here, that is segment of a circle. Segment of a circle. Segment of a circle is the region between chord and corresponding arc of a circle. It is the region between chord and corresponding arc of a circle. Let us draw another circle of radius R with center O. Here we draw a circle like this. Take a center as O. To segment, the definition is a line as a region between two radii and corresponding arc of a circle. Like we draw the two radii of this circle, or we take any, this one is the radius OA and another radius is OB. A region between chord and corresponding arc. For chord we have to draw a line segment AB, a region between chord AB and corresponding arc of a circle. This one, this shaded part is known as segment of a circle. This is, but this segment is minor segment of a circle. Minor segment of circle. And this whole part is known as major segment. This is major segment. It is major segment. Major segment of a circle. So sector is a region between two radii and corresponding arc of a circle. But segment is the region between chord and corresponding of a circle. And this segment ACB here is the minor segment. This one divides a circle into two unequal segments. One is minor segment and other is the major segment of a circle. Now we have the sixth point here, that is quadrant of a circle. That is quadrant of a circle. A sector is said to be the quadrant of a circle when the central angle is equal to 90 degrees. Means if we draw a circle here like this, a circle, we take center point as O. If we draw two radii, this one OA and this is OB, and if this angle, or we draw this chord as well, So this, if this center angle is equal to 90 degrees, then OCB is said to be the quadrant of a circle. Means sector is also a quadrant is said to be also a quadrant when the angle, central angle is equal to 90 degree, then the sector is said to be a quadrant of a circle. So discussing these two basic terms, that is chord, diameter, central angle, sector of a circle, segment of a circle, and fourth one is quadrant of a circle. Quadrant of circle. Now, in this chapter, we have to find out the areas of a sector and areas of a segment and length of an arc. Let us first discuss how to find out the area of a sector by using the formula. Consider here we draw a circle of radius R and center O. Now another point is area of sector. Area of a sector. We know that sector is a region between two radii and corresponding arc of a circle. Means if we draw a circle here, this one, and we take center as O here and draw two radii, let it be OA and OB. We know that this, and we take this point C here, OACB is a sector of a circle. How to find out the sector of a circle? That means this angle is known as central angle, or this one is known as the sector angle. We have to find out the area of this OACB. We know that when a circle is considered to be a sector, when the measure of a central angle is 360 degrees. That is, if the degree measure of here is 360 degrees, then the circle is said to be a sector. Then the area of, or when the central angle of a circle is 360 degrees, or when the central angle, when the angle at the center is 360 degrees, then the figure so formed is said to be a circle. Means when the angle at the center is 360 degrees, then the area of a sector is equal to pi r square, because when the angle is 360 degrees, then we have a complete angle that is 360 degrees. So 360 degrees is an angle of a circle. That means, so when angle at center is equal to 360 degrees, then area of sector is equal to pi r square. Pi r square. When the angle measure is 360 degrees, then the area of a sector is equal to pi r square. Now similarly, when angle at the center is equal to 1 degrees. If the angle at the center is equal to 1 degrees, then area of sector is equal to 1 divided by the complete angle, that is 360 degrees, into pi r square. Because when angle at the center is 360 degrees, then the area of sector is equal to pi r square. And if central angle is 1 degree, then area of a sector is 1 divided by 360 into pi r square. Now, when angle at the center is equal to theta degrees. Is equal to theta degrees. Here, let us take this as theta degrees. Then area of sector. Area of sector. Then area of a sector. We call the sector as here OACB is equal to theta divided by 360 into pi r square. This is the formula for finding the area of a minor sector when the sector angle is equal to theta, and therefore the area of this sector, this one, is equal to theta divided by 360 into pi r square. Now, when the central angle is 360 degrees, then the figure so formed is a circle. So, when central angle is 360 degrees, then the area of the sector is equal to pi r square, because here circle is complete angle. Now, here when angle at the center is 1 degree, then area of a sector is 1 divided by 360 complete angle into pi r square. Similarly, when the angle at the center is theta degrees in general, then area of a sector OACB is equal to theta divided by 360 into pi r square. This is the formula for finding the area of a sector when the angle is here in general theta degrees. Now, another point is here area of a segment of a circle. Area of a segment. How to find out the area of a segment? Now, another point is area of segment. Area of a segment. Now, consider a circle. This one be the center of a circle, and we call it as O. This is the radius OA. One is another radius OB, and this one let the radius be R, and this one be R. And if we draw the A and B, join A and B, we get a segment here, this one, shaded region. This shaded region is said to be the segment of a circle, and we take another point here, that is C. So the segment here is A, C and B. Clearly, we have to find out the area of this ACB. By observing the figure, we can find the area of ACB as, that is area of OACB, complete sector, minus area of this triangle. Area of this triangle. Now, we know that if this angle is equal to theta, this angle is theta degrees. Now, area of a segment. Area of segment. Area of segment, that is minor segment ACB, is equal to area of sector, area of sector OACB, OACB minus area of triangle OAB. We know that the area of a sector is theta divided by 360 into pi r square. So, area of segment ACB is equal to area of a sector OACB. We know that area of a sector is theta divided by 360 into pi r square minus area of a triangle OAB. But the question arises here, how to find out the area of a triangle OAB. OAB, for this triangle is an isosceles triangle because the two sides OA and OB are same. For this triangle, we draw a perpendicular on side. This is perpendicular, and let the perpendicular be M here on side AB. If it is perpendicular, then this one be the 90 degrees angle, and this one is also 90 degrees angle. So, when two sides of a triangle are given and we draw a perpendicular to it, then this perpendicular divides the triangle into two triangles or congruent triangles. If this complete angle be theta degrees, that means this angle is theta divided by 2, and this one be theta upon 2, because OMA triangle and triangle OMB are congruent to each other by CBSE. This angle is equal to this angle, that equals, if the complete angle is theta, so the two parts equals to theta divided by 2 and theta divided by 2. For this triangle, we should find the base and altitude of a triangle. Clearly, the base is here, AB side, and the altitude is here, AM side. We have to find out the base AB and the altitude OM. So now in triangle, and we call this equation as first one. Now in triangle OMA, we use here trigonometric ratios. So we have to find out perpendicular and base if we take this theta divided by 2 an angle. So we use here, we can apply cos theta here, or cos theta by 2. Cos is equal to curly black here, base upon hypotenuse. We know that base is the side adjacent to the angle and hypotenuse is the side opposite to the right angle. Here the angle is theta by 2. It is adjacent side is OM. So here we can apply cos of theta by 2 is equal to curly black here, base by hypotenuse. What is base here? Base is OM. It is OM divided by hypotenuse. Hypotenuse is here OA. That equals to OM divided by OA. Clearly, on observing the figure, OA is equal to the radius of the circle. We can write OA is equal to R. That implies cos theta by 2 is equal to OM divided by R, or OM. If we transpose this R to the left hand side, we get OM is equal to R sine or cos of theta by 2. OM is the altitude of a triangle, and it is equal to R cos theta divided by 2. Similarly, taking the same triangle, now here sine theta by 2 for the same triangle. In triangle OMA, sine theta is some people have, means perpendicular divided by hypotenuse. What is the perpendicular here? Perpendicular is the side opposite to the angle. That means we take angle theta by 2 here, this theta by 2, the opposite side is AM. So this is perpendicular, that means AM divided by hypotenuse is the same, OA. Now sine theta by 2 is equal to OAM divided by OA. OA equals to radius R. That means AM is equal to R sine theta divided by 2. Now AM is the base, half part of the base, because base is here total AB line, and we have to find out, we are finding this AM is equal to R sine theta by 2. Similarly, BM is equal to the same R sine theta divided by 2, because this perpendicular OM divides the triangle OAB into two congruent triangles. So CPCT, AM is equal to BM. So AM is R sine theta by 2. Similarly, BM is R sine theta by 2. Now, what is the length AB here? It is also the base of the triangle OAB. Now AB is equal to AM plus BM. That means R sin theta plus R sin theta, or we can write it as twice R sin theta. It is twice R sin theta by 2. So it is R sin theta by 2. This is R sin theta by 2. When we add the 2, we get the total line AB is equal to R twice R sin theta by 2. Now for this triangle OAB, we have now base AB that is equal to R sin theta by 2, and the altitude OM is equal to here R cos theta by 2. So what is area of a triangle now OAB? It is 1/2 of base, that is AB, into altitude, that is OM. Now area of a triangle, now here area of this triangle ACB, or area of the segment ACB, area of a segment ACB is equal to area of a sector OACB minus area of this triangle OAB. We can write it as that equals to theta divided by 360 into pi r square minus area of a triangle. Clearly it is 1/2 of base is AB, it equals to twice R sin theta by 2 into altitude is OM, that is cos, R cos, or it is R cos theta by 2. This 2 and this 2 cancel. We get it is theta divided by 360 into pi r square minus R into R is here R square sin theta by 2 into cos theta by 2. This is the formula for finding the segment of a circle, area of the segment of a circle. If it is the minor segment, then area of the minor segment ACB can be found by using this formula, theta by 360 into pi r square minus R square sin theta by 2 cos theta by 2. Now question is here, if this angle is equal to 90 degrees, then the triangle OAB is a right triangle. Then we use the formula 1/2 of base into altitude for finding the area of the triangle OAB. Now if the angle is not 90 but it is 60 degrees angle, then this triangle is said to be an equilateral triangle, and we use the formula of an equilateral triangle, that is square root 3/4 into side square is the area of this equilateral triangle. Now when in general, this is the general formula, when it is the general theta, then we draw the perpendicular, we get two triangles. On simplifying, we get the area of the segment is theta by 360 into pi r square minus R square sin theta by 2 cos theta by 2. This is the formula for finding the area of segment of a circle. Thank you for today's video lesson.